Part 4 Performance of a network. Performance of a network pertains to the measure of service quality of a network as perceived by the user. There are different ways to measure the performance of a network, depending upon the nature and the design of the network. Finding the performance of a network depends on both quality of the network and the quantity of the network. Let's look at parameters for measuring network performance like bandwidth, latency or delay, and throughput. I'm gonna begin with bandwidth. Bandwidth is the only one component of what an individual sees as the speed of a network. Bandwidth means capacity and speed mean transfer rate. Bandwidth in hertz. It is the range of frequency contained in a composite signal or the range of frequency a channel can pass. For example, let us consider the bandwidth of a subscribed telephone line as 4K Hz. Bandwidth in bit per second is referred to the number of bits per second that a channel, a link, or rather a network can transmit. For example, we can say the bandwidth of a fast Ethernet network is a maximum of 100 megabps, which means that the network can speed 100 megabps of data. There exists an implicit relation between the bandwidth in hertz and the bandwidth in bit per second. An increase in bandwidth in hertz means an increase in bandwidth in the bit per second. The relationship depends upon whether we have baseband transmission or transmission with modulation. Latency in the network during the process of the data communication. Latency, also known as a delay, is defined as the total time taken for a complete message to arrive at the destination, starting with the time when the first bit of the message is sent out of the source and ending with the time when the last bit of the message is delivered at the destination. The network connections where small delay occur are called low latency network, and the network connections which suffer from long delay are known as high latency network. High latency leads to the creation of bottleneck in any network communication. It stops the data from taking full advantage of the network pipe and conclusively decrease the bandwidth of the communicating network. The effect of the latency on the network bandwidth can be temporary or never-ending depending on the source of the delay. Latency is also known as a ping rate and is measured in milliseconds. In simple means, latency may be defined as the time required to successfully send a packet across a network. It is measured in many ways like round trip, one way, etc. It may be affected by any component in the chain utilized to vehiculate data, like workstation, wiring, router, LAN, and server, and eventually may be limited for large network by the speed of the light. So latency equal propagation time plus transmission time plus querying time and plus processing delay. Throughput is the number of messages successfully transmitted per unit time. It is controlled by available bandwidth, the available signal to noise ratio, and the hardware limitation. The maximum throughput of a network may be consequently higher than the actual throughput achieved in everyday consumption. The term throughput and bandwidth are often true of at the same, yet they are different. Bandwidth is the potential measurement of a link, whereas throughput is an actual measurement of how fast we can send data. Throughput is measured by tabulating the amount of data transferred between multiple locations during a specific period of time, usually resulting in the unit of bit per second, which has evolved to byte per second, kilobyte per second, megabyte per second, and gigabyte per second. Throughput may be affected by numerous factors such as the hindrance of the underlying analog physical medium or the available processing power of the system component and end user behavior. When numerous protocol expense are taken into account, the use rate of the transfer data can be significantly lower than the maximum achievable throughput.